Assalamu alaikum wa rahmatullahi wa barakatuh. In this video, we are going to complete our chapter about dilation. The objectives are: apply the properties of dilation, identify the identity, the invariant point, and the inverse of a dilation, identify the composite of two or more dilations and the composite of a dilation and a translation. Write the complex form of a dilation. Let us first remember this remark. T is an identity if and only if T of M equal M for every point M in the plane P. B is an invariant point by T if T of B equal B. The third remark, if T of M equal M prime, then the image of M prime by the inverse of T is M. The fourth remark, T round T prime of M equal T of T prime of M. Now, we have here these properties. Given H be a dilation with center O and ratio K, such that K is different from 0. First, the identity of H of center O and ratio K is the dilation of center O and ratio 1. The invariant point by H of center O and ratio K is the center O, so that means H of O is equal to O. The inverse of the dilation of center O and ratio K is the dilation of center O and ratio 1 over K. That means if H of M equal M prime, then the image of M prime by the inverse of H is equal to M. Now, if we have these two dilations, H1 and H2, then the composite of the two dilations, H1 and H2, follows the chart at the right. First, if H1 and H2 have the same center, O. The second case, if they have different centers. If they have the same center and the product of their ratios is 1. If they have the same center but the product of their ratios is different from 1. If they have different centers and the product of their ratios is 1. If they have different centers but the product of their ratios is different from 1. Each one of these cases will give the following result. First case, if they have the same center and the product of their ratios is 1, the composite of these two dilations is the identity. If they have the same center but the product of their ratios is different from 1, then the composite of H1 and H2 will be the dilation H of center O and ratio, which is equal the product of the ratios K1 and K2. But if they have different centers and the product of their ratios is 1, then the composite of H1 and H2 will be the translation of vector V. Finally, if they have different centers and the product of the ratios is not equal to 1, then the composite of the two dilations will be a dilation of unknown center to be determined under a certain given, and the ratio will be the product of the two ratios K1 and K2. The composite of a dilation of center A and ratio K and a translation of vector V is a dilation of unknown center to be determined and a ratio K, which is the ratio of H. Now, remember these rules that are mentioned in the first slide. Let us go to the example. Given the segment AB, given the dilations H1, H2, H3, and H4, complete. First, the inverse of the dilation H1 is, yes, as you said, the dilation of center A and ratio half. The image of A by H2 will be, yes, A as you said, because it is invariant point, because it's the center of H2. The pre-image of B by H3 will be, yes, it will be B because H3 is of center B, so B is the invariant point for H3. H1 round H2 is, yes, it will be a dilation of center A because H1 and H2 have the same center A, and the ratio of this dilation will be the product of the ratios of H1 and H2, which is 2 times 3, which is 6. Now, the composite of H2 and the inverse of H2 is, yes, as you said, it is the identity because H2 and the inverse of H2, they have the same center and the product of their ratios is 1 because if H2 is of ratio 3, that means the inverse of H2 will be of ratio 1 over 3. and all the rules here are mentioned in the table to the right. Now, part 6. The composite of H2 and H3 is, yes, as you said, it is a dilation of center to be determined because H2 and H3 are of different centers, and the ratio is the product of their ratios, 3 times -2, so it will be -6. Now, the 7th example, H2 round H4, it will be, yes, it will be a translation because they have different centers and the product of their ratios is 1. Now, part 8, the composite of a translation of vector AB and H3, it will be, yes, it will be a dilation of a center to be determined and a ratio -2, which is the ratio of H3. Now, let us go to the application 1. Given the segment AB, given these dilations, identify the transformation T in each of the following cases below. That means give the nature of this transformation and the elements of this transformation. First example, the transformation T equal H4 round H3. Please stop the video and try to solve this example. The solution of the first part, T is a dilation with center B and ratio 1/3 multiplied by -2, it will be -2/3 because the composite of two dilations having the same center and non-reciprocal ratios means the product of the ratios is not equal 1. Thus, T will be a dilation of center B and ratio -2/3, which is the same center as H4 and H3. The second example, find T equal H1 around the inverse of H1. Please stop the video before solving this example. T is an identity. T will be the identity because it is the composite of two dilations having the same center and the product of their ratios is 1 because the ratio of H1 is 2 and the ratio of the inverse of H1 is half. So the product of the ratios will be 1. So the ratios are reciprocal to each other. Thus, T will be equal to the identity. We are going to complete the application 1. Given the segment AB, again, these are the dilations. The third part, find T, which is H1 round H3. Again, stop the video before seeing the solution and try to solve it. T will be here a dilation with center L and ratio, the product of the ratios of H1 and H3, which is -8, which is -4, because T is the composite of the two dilations having distinct centers and non-reciprocal ratios. So finally T will be a dilation of center L, which is not same center as H1 or H3. Thus T will be a dilation of a center L to be determined and a ratio -4. Note when we say that here to be determined that we need a certain given to locate this point L or to find its position. Here we must precise the position of L according to two fixed points or a certain fixed point. That means by a geometric way, find a relation that can help us to locate the position of L in the figure. How to do that? Here, the image of B by this transformation T will be H1 round H3 of B equal H1 of H3 of B equal H1 of B because H3 of B is B because B is the center of H3, so it is invariant point by H3. So H1 of B finally will be a new point B prime. So AB prime will be 2AB because B prime is the image of B by H1 and H1 is of center A and ratio 2. As we remember in the first video of this chapter, if H1 of B equal B prime, that means AB prime will be K AB. Here the ratio is 2, so AB prime equal 2AB. First, before we continue, why we select the point B to find its image by T? In order to precise the position of L, finding the image of a fixed point by T can help you to locate the position of L. So you select one of the fixed points in the figure. Because AB is a given segment and A and B are the centers of H1 and H3, you can select one of them to find its image by T, and this can help you to find the position of L, which is the center of T. So here we select the point B to find its image by T. Another student can also select the point A, for example, to find its image by T, and continue by the same way that we are going to do here. Let us continue. Thus here T of B equal B prime. Now we also proved that T is a dilation of center L and ratio -4. And using the result that T of B equal B prime, we can say that LB prime will be equal to minus 4 LB. Now we can use Chassis rule in order to keep the point that we are going to locate it or to precise its position, which is L, as we remember in the first video. So we introduce the letter B and we do the ordinary calculations. We get here BL vector equal fifth BB prime vector. Finally, T is a dilation of center L and ratio minus 4. And as you see here in the figure, that BL vector equal 1 over 5 BB prime vector and AB prime vector equal 2AB vector. And all these points in the figure are fixed points. And so here we define exactly where is the position of L. Let us continue the application. Given the segment AB again, and these dilations now, find T, which is equal H4 round H2. Try to solve it alone. Yes, T is a translation with a vector V because the composite of two dilations of distinct centers and the reciprocal ratios is a translation. Here, the problem is to determine the vector V because the element of the translation is its vector. So we must precise what is this vector V. We will use the same technique as the previous part by finding the image of the center of H2 by T in order to define this vector V. Now, T of A equal H4 round H2 of A equal H4 of H2 of A equal H4 of A because H2 of A is A, because A is the invariant point with respect to H2. Finally, H4 of A equal A prime. That means, using the definition of a dilation, BA prime equal 1 over 3 BA. Thus, T of A equal A prime. But we know that T is equal to the translation of vector V, as we proved in the first. And T of A equal A prime, so we can deduce that TV of A equal A prime. Thus, the vector V will be AA prime. The question is the vector here, V, which is equal AA prime, is a fixed vector? The answer is yes, because A is fixed and A prime, which is the image of A by T, also will be fixed because BA prime equal 1 over 3 BA vector. That means BA prime equal a constant times a fixed vector. That means A prime also is fixed point. So the vector AA prime is fixed. So the vector V is fixed. Finally, the vector V that we are searching for it is the vector AA prime. So T will be a translation of vector AA prime. Here is the figure that illustrates our concept. This is our vector V. Let us go to the second application. Given the segment AB, consider dilation of center B and ratio minus 2 and the translation T of vector AB. Given the transformation T equal H round T of vector AB. The first part, determine the image of A by T. The second part, identify T, means find the elements of T and the nature of T. Before we start, try to solve it by yourself. T of A equal H of T of vector AB of A equal H of B because the image of A by the translation T of vector AB it will be B. So finally H of B equal B because B is invariant point with respect to the dilation H. Finally T of A equal B. Now the second part, what is the nature of the transformation T? T is a dilation of center L and ratio minus 2 because the composite of a dilation and a translation is a dilation and of ratio, which is the ratio of the dilation H. And we need only here to precise the position of L, which is the center of this transformation T, which is the center of this dilation H. How to do that? As we said, we take a point and find its image by T. And this was done in the first part when we said that T of A equal B. So T is a dilation of center L and ratio minus 2 and T of A equal B. The combinations of these two ideas give that LB vector will be minus 2LA vector. And again we use Chassis rule and we do some calculations. We get AL vector equal 1 over 3 AB. In this case we precise the position of L exactly. Here is the figure and here is the position of L. Now we are going to talk about the complex form of a dilation. The complex plane is referred to a direct orthonormal system, OUV, given the points M and M prime with respective affixes, Z and Z prime, and the dilation H of center L and ratio K, with K is different from 0, that transforms M onto M prime, that means H of M equal M prime. Write the complex form of H. That means writing Z prime in terms of Z. As we know that Z is the affix of M and Z prime is the affix of M prime. And since H of M equal M prime, that means Lm prime equal K Lm vector. And this vector relation will be transformed into a complex relation that means Z prime minus Z of L equal K multiplied by Z minus Z of L. So finally Z prime equal Kz plus Z of L minus Kz of L. And in a simple form, the complex form can be written in the form Z prime equal AZ plus B. This form is called the complex form of annihilation, where A here equal to the ratio K, and B will be equal to 1 minus A multiplied by the affix of L, which is the center of the dilation H. Here is an example. Each of the equations below is the complex form of a transformation. Identify T. First part, Z prime equal to Z plus 1 minus I. Before we start, try to think what is the nature of this transformation T. Yes, as you said, Z prime is the complex form of a dilation with center L and ratio 2 because it is similar to the form Z prime equal AZ plus B. By comparing, here A will be the ratio 2 and B here equal 1 minus A times Z of L. So Z of L will be B over 1 minus A. So Z of L equal 1 minus I over 1 minus 2 equal minus 1 plus I. In the second example, you can see that also it is a dilation with center O and ratio minus 4. Try to think why the center is O. In the third example, you notice that the number multiplied by Z is not a real number. That means this transformation is not a dilation. It will be, yes, as you said, it will be a rotation of center L and angle minus pi over 4. And try to remember how to find the angle of the rotation and the center and the affix of the center using the complex form. Finally, the third application, write the complex form of each of the following transformations, T given below. First, T is a translation with vector u of components 0, minus 3. Stop the video and try to solve it alone. The solution is T of Z equals Z prime equal 1Z plus 0 minus 3I. So Z prime equals Z minus 3I. The second part, T is a rotation with center O and angle pi over 3. Yes, Z prime equal e to the exponent pi over 3I Z equal 1 over 2 plus radical 3 over 2I Z. Finally, the third example is about dilation. Given the center of this dilation 1, 1 and of ratio 3, yes, Z prime equal 3Z plus B because the ratio is 3. And to find B equals Z of L multiplied by 1 minus A, it will be 1 plus I multiplied by 1 minus 3. Finally, B equal minus 2 minus 2I. So Z prime equal 3Z minus 2 minus 2I. Here is your assignment. This is the summary. Thank you for listening. Assalamu alaikum wa rahmatullah.